Hi, welcome to the stream. Today we will continue the stuff that we did last time. We will be making our library for procedural path animation. But we will do this in an hour, so I will leave you here for now with some stable diffusion. Hopefully it's not going to crash my PC. I have just 8 GB of memory and running those animated diff models takes a lot of memory. So the stream may become choppy, but I will turn it off before we start properly. Okay. And let's see if this crashes. I expect severe FPS drop. Unfortunately, we're not going to see any animated diff, but you know, instead of doing animated diff, I can just run good old stable diffusion. Yeah, like so. So, see you at 11 when the stream starts.
Fabio just followed.
before we start the stream, we can probably play a little bit with Stable Diffusion. I wanted to try some animations, but my GPU doesn't have enough memory to stream and do animate diff at the same time. So instead, we'll just play with some prompts. I'm going to use a trick that I found recently, which is very good for coming up with nice prompts. And this is to use language model to figure out the names of the artists that paint in a given style. I will make it larger. So what I'm doing here is I'm asking a tiny LLM model that I have on my machine to basically give me some ideas, and we will see how they influence the pictures that we generate here. Let's see, how was that? This is nice, but this is more cyberpunk. I don't want that. Marcello Mizzoli. Yeah, and this is what I really like. This type of industrial design where we have those smooth shapes, plastic. I really like that. Luigi Verona. This might have been a confabulation. I don't see an artist named Luigi Verona, at least not a recent one. There was one in the 19th century. That's too early for futurism. Okay, come about. Let's try this one. Yeah, this one is great. And we have the next generation coming up. So this is going to use the new prompt. It is slightly more colorful, maybe slightly more geometric than the previous generations. But I don't see too many futurism in here. Let's switch from landscapes to some industrial design, maybe. That looks like straight out of 1984. I would like to highlight the names of those artists, and let's check more of them. Soul Bass. Yeah, I recognize this style. The guy made posters for Hitchcock movies. But this is not what I'm aiming for. Javier Mascaro. A little too grunge or steampunky. Let's check this one. This is some really nice furniture. Yeah, let's take a little bit of this style. So we have this double exposure term here, and I'm curious how it influences the model. I think the reason that model generates those kind of always two objects, like when we were creating mountains, we had mountains above and mountains below. So we could actually keep this one. Let me try removing it and see how it changes the results. Instead of dark and moody and surreal, let's go for yeah, now we have much nicer generation. This style, this is what I like. This is like modern futurism, like sci-fi fiction. And this is the mid-century futurism. So, old Star Trek the original series, Space Odyssey, and so on. I'm thinking of trying maybe something else. So this is Stable Diffusion 1.5, so we can work with, okay, like, so Stable Diffusion 1.5 is decent, right? But after it came out like quite a long time ago. Since then we had some new models. So let me disable AutoQ. And somewhere I had a workflow which uses Stable Diffusion Turbo, and that one is much faster, and I think it's better at following the prompt. So let me see. And apparently I don't have the model. So let me download it quickly. And the installation is in progress. By the way, thank you for the follow, whoever followed me a couple of minutes ago. I have this problem that there are so many bots on the chat that I cannot really distinguish actual viewers from bots. Hi, I see a couple of new people. So what we are doing right now, the stream is not starting yet. We will be doing some path animation. We have this nice library to draw paths composed of straight lines and curves, and we're making sure that they can... We're creating some C++ classes that we can grow and shrink them dynamically. So we will be doing some geometry here, but before the stream is starting, we're playing with Stable Diffusion. And I just downloaded the missing model, so... Let me... Yes. So now we're switching from Stable Diffusion 1.5 to Stable Diffusion XL. This is a slightly newer model, and the thing about it is that steps is equal to 1. So it may use a little bit more memory, but basically it can generate whatever we tell it in one step. So let's try this thing. I would say it's decent. We don't need this one anymore. Scheduler. Yeah, we don't need scheduler. And now I am a little bit concerned about saving those images because we will have a lot of images. So instead, I will just leave the preview. So let's tell it to AutoQ and let's go. Let's switch from joystick to something else. Well, we're working on the hotkey object, so let's try this. Yeah, those models are not great at industrial design. Maybe we could play with some landscapes. We had mountains just a few minutes ago. Now this is nicer. Now we are getting a mix of this painting style, nature painting, and those artists. Those are nice pictures. really nice landscapes.
NA947657887 says, hey, I have a random and funny question.
Go for it.
NA947657887 says, if you could choose anyone to see get tickled as a prank, who would it be? LOL.
I did try this with my dog, but animals don't really have tickles.
NA947657887 says, my choice is Justin Bieber LOL. That would he funny, as he's quite arrogant and he'd try and act tough LOL.
So there is fun fact about Justin Bieber. So I used to work at Google for some time, and I had some friends at YouTube. Friends who were moderating YouTube specifically, and data analysts and so on. So YouTube, he may be famous as the most popular, like pop, teenage pop musician a couple of years ago, but one of his tracks is also the most downvoted clips on YouTube ever. It's sitting at a couple billion downvotes, which is impressive. It's a record in itself. So there are so many people that don't like Bieber that they actually put him on top. And this is probably one of the reasons that Google kind of eventually removed the downvote button, because it became like a
NA947657887 says, oh wow, that's interesting, haha.
Let me send some messages out.
NA947657887 says, do you think he was a funny choice?
Yeah, I think so. It's hard to get access to Bieber though, so it might be hard to tickle.
NA947657887 says, haha, yeah, it was more hypothetical, just a silly idea, haha. NA947657887 says, it would be funny him crying laughing but acting tough, lol.
It would indeed.
NA947657887 says, you have a good sense of humor.
Yeah, so this is the plan for today. We are going to finish this library, which we started during the last stream, and yeah, we'll see where it goes. We'll try to use it to tweak the hotkey object. When I look at differences between generations by Stable Diffusion 1.5 and Excel Turbo, it looks to me like 1.5 was creating nicer compositions. In this Excel version, the image seems to be kind of low contrast and fairly generic. See, each generation that we get, it's very similar to the previous one. It doesn't have any like novel, like creative combinations of those shapes. Like when I said in this prompt, we have abstract something at some random time of the year with some flowers. Maybe those flowers are influencing the model too much. Let's remove the flowers. But everything looks like oil painting. I don't like that. Maybe we can use the negative. I'm not sure if SDXL even takes negatives. They probably don't work here. Let's change this to digital art. Let's make it more dramatic. When we see this car, I feel we keep seeing the same car over and over. It's a pretty car, but it seems very boring. Like, come on, Stable Diffusion, give us something nicer. Yeah, some of the results are really nice. This is the spaceship at Automat time. So the big difference between Stable Diffusion XL and 1.5 is that I can actually run XL and the stream works, kind of. I get like 40, 60 FPS, and when I was doing 1.5 I was getting like 10 to 20 FPS. It's too bad that XL XL Turbo is not so great at prompt following. the best one that we could run would be the regular stable XL without the turbo. The problem with XL, at least on my PC, is that it requires more steps to generate the image. And like the difference between baseline and turbo is that the baseline is slower. No surprise. Yeah, the sunset images are very nice. Let's try New Year celebration. This is nice. The lake, the pictures of lakes are always super pretty. Somehow XL Turbo is very good at creating lakes. Yeah, like this one. Or this one. You know what? When I look at this, do we even? Because when I see that this node runs, the decoding is actually kind of slow. So if we could just make sure that this always executes. So let me remove this thing. Q. Prompt has no outputs. It does. I mean, come on. How can I force the execution of this thing? Okay, let's see, what can I do with... so, the problem I'm trying to solve right now is that I have this sampler which can run stable diffusion, but I don't want to decode this, because I have this like very fast decoder which shows me those previews. I don't want to save those images. This decoding is slow. So I'm trying to find a node which will let me use this, which will allow Comfy to still run even though there is no output. Because Comfy UI tries to optimize the execution, it only looks at, okay, what files are you saving? And it follows the computation graph backwards from that. So it only executes the nodes that it has to. But right now, there are no outputs. So this thing doesn't really execute. I'm looking for some dummy output that will let me just execute it and drop it. Can I somehow mark this as output node? It is already marked as always. Nah, I guess I probably have to decode. Whatever. Preview. Let's go. When we do the style, instead of merging those together, let's just pick one of them. So we are either picking Marcello. This is, he did some industrial design. Yusaku Kamekura, he did some art. This is what I think when somebody tells me like 80s futurism. And Mattia Bonetti, he was furniture designer. Let's remove the time of the year, because I want to see slightly different versions. Okay, removing abstract makes the pictures less like paintings. Yeah, I feel that now our digital art is picking up. Just for fun, let's try photo. Yeah, and photographies are also nice. Okay, so the plan for today is we're not going to play with Stable Diffusion. The plan for today is we're going to write some C++ to do path animations. So let me stop this thing. Kill Stable Diffusion. And let's run Automat. I'm not sure if it will build. Oh, it did build. So we're working on this hotkey object. We already got the logic working kind of on Linux. So this hotkey object actually generates events when I enable this and press the hotkey. We will get events. Now, this red line that you see here, this is what we are actually be working on today. So this is our library to do path manipulation. It allows us to draw the line which goes around some shape and then dynamically shrink it or enlarge it. Right now it's broken, but we are going to fix this. And so we will be doing some geometry, so I will try to paint some stuff. The situation that we have with this library is that we have a sequence of points. Let's say we have point A and point B, to use the same notation from the last time. And each point contains a change, like an angle, a change of angle from the previous line, and a distance. So we have this angle beta. And the problem that we are trying to solve right now is to dynamically offset the shape that we are drawing. Right now we have some bugs, and during the last stream we were doing lots of math trying to figure out the proper way to do this. And at the end of the stream, we took the math that we came up with and we pasted it in Wolfram Alpha to simplify it. And Wolfram Alpha showed something very fun, because Wolfram Alpha told us that we had this huge expression with lots of trigonometric functions, and Wolfram was able to simplify it to cotangents of beta by 2. So the full expression for our kind of delta L, because like the length of this segment is called L, and when we want to offset it, by some offset, right, the point A becomes A prime, it moves here. The point B becomes B prime, it moves here. And what we are interested is this point here. This is the point C. So we figured out that the point C is going to lie on the intersection of this line, which is the line B offset by our offset S. Also, the name of the offset was S. And the reason we were looking for C is that if we want to change the shape, our shape, we need to change the lengths of paths. So this point C projected here will tell us how much we have to shrink L. So the expression for this delta L, let's call this delta L, and this is delta L. This difference from original L to the slower position, it was something, at least according to Wolfram Alpha, it was S times cotangents beta by 2, which wasn't working. But when I looked at this after the stream, I realized that this shape that we have here, the one created by the point B and C, this is a parallelogram. And yeah, it's obvious that from the geometry that the angle that we have here, this is pi minus beta. And the angle from A, B to C, this angle here, this is going to be, so we take pi, we subtract beta and we divide by 2, and we have this angle from A, B, C. So we could have just thought about this and looked at this more, and we could avoid a lot of math. And also, because we kind of messed up the angles, the expression wasn't entirely correct. So actually it should be pi minus beta by 2. So this is probably why it wasn't working last time. So we're going to fix this today. And also, I had some other ideas for improvements to our library. So we will do them, but in a proper time. First, let's try fixing the base library. So let's start VS Code. Open the directory, and this window we can probably close. We don't need this terminal. We will use the built-in terminal from VS Code. Let's go to our ArcLine and the offset function. So this is the part which I will make this larger. And this is the part which adjusts the lengths of the segments. So the part that we have for arcs is correct. So we can draw nice arcs. Let's do an example. So if we have an arc line let's call this L2. We are drawing our sample line composed of polar line of arcs. Why doesn't it work? Oh, this is polar line too. I wanted to do arc too. See? So we have this line, which looks great. Let's actually create a closed shape here. So we have this funny shape here, and this part of animation should already work. Yeah, so we have this growing and shrinking shape. And all the math that we use here is, yeah, I guess it's correct. I guess the stuff that we use here is fine. Now we have to repeat the same thing for our straight line segments. Let me fix the test shape that we had here. Okay, now our test shape is, it's basically a pentagram, but not, I don't know what's the proper name for this. It's just a shape, a house envelope shape. It seems like it's almost shrinking correctly, but not quite. This edge is definitely shrinking correctly, moving correctly. So it's moving by this distance, like 2 millimeters. But this one is moving by much more. So let's try to fix the equations. So here we'll have something like this. I think this is almost correct. So only the final segment isn't behaving correctly. But I think the final segment is actually missing. So if we add the line 2, 0, 0, this is still slightly wrong. I feel that this line is going slightly down here and slightly up. And this shouldn't be happening. Also here we have to add another line. Yeah, so basically we have this zigzag shape. It shouldn't exist. This should really be overlapping. Those two lines should be one over another. But this is a very small error. Maybe it's caused by the order of operations that we have in the offset functions. I think all of the offsets in this line are positive. So this will give a positive value. Okay. Maybe this should be plus. It should not. Well, there is one more thing I wanted to change, and it may actually simplify the code a little bit. So that this issue will go away. Okay, the thing that I wanted to change was the direction, the winding direction. I think the direction which we are using right now, where positive angle means turning right, it messes up the math a little bit, because in math, usually, when the angle increases, the angle turns to the left. So this is one thing I'd like to change. I think most of the sign issues will become either go away or will become much easier. So we have this comment which says when the relative angle is positive, the light turns to the left, yes. And our turn function should change. Oh, we'll have to do some debugging. So let's see where we could have issues right now. I think things are behaving crazy right now. So let me remove most of this code and let's create a very small test case. L2, I will comment this out. Let's try. Very simple test case. And we don't need the offset function yet. Okay, so what is happening here? We are passing our angle as positive value, and if the value is positive, we should turn left, but we are turning right. This is wrong. So I think this part is wrong. Well, it seems worse because the end position, the end cursor jumped from the end of the line here. But I think this is better because below Shift and Control, this is where the center of the rotation should be right now. So we rotated around the correct center of rotation, but in the wrong direction. So let's change that. We are doing this thing. And this is good. We are calculating center correctly. Center plus polar. Okay, now the endpoint is in the correct position. So the thing we have to fix right now is the toSkia function, which converts our path representation to something that we can draw. Set not to path. Yep, we'll just flip the center and maybe that's enough. That's not enough, but yeah, the center of the Skia circle is now in the correct position. This is good. Yes, we should remove this minus from there. We fixed one thing, but that's not all. Start angle is also incorrect. The start angle should be maybe minus 90 here. That seems correct. So we started in the center, pointing up. Let's see if the complex shape looks okay. Yeah, the complex shape looks fine now. It's not growing correctly though. It's offsetting too much to the left. It should stay in its own place. But that's good. Now we can work on the offset function again. Yeah, already looks good. And in our function here, we could actually draw this before and after we offset it. Yeah, so we see the initial path and the path which is shrunk and grown by the given offset. Yeah, and at every point it's behaving nicely.
Square triangle just followed.
Thank you, square triangle.
Square Triangle says hi Merrick. Are you planning to add some noise and curves for mouse movements to be human-like? Otherwise any anti-bot software will simply block Automat from further int irrations.
It's funny that you mentioned this because I used to work on the anti-abuse team at Google. And yeah, you have some valid points. Those paths that we are drawing here, I don't think they will be used to actually control the mouse movement. They will actually be used to draw widgets and those virtual machines. For mouse movements, I think we will have dedicated objects that will record mouse movement and replay it. So that if you can move your mouse yourself, in a whatever fashion you want, you will be able to replay that. At least that's my plan. As you can see, I'm still working on the visuals, so I still have this hotkey object, those couple of mouse press and release objects, but I see that it takes a lot of time to create each one of those objects. So what I want to do is to actually create a, just temporarily, like an object which will allow you to type, arbitrary Python code. And the idea is that you will mix this block with Python code with other objects. So, whatever kind of logic you want to embed there, it should be possible. And then over the time, I'm going to add more, nice machines that will replace blocks of Python code, so that, normal people can also do this kind of stuff. Yeah, we just got a small issue. But I guess the stream should be back online now. Yeah. Well, let's get back to coding. So next thing I wanted to do was to check if the straight lines work correctly. Let's draw a test example with just a square. So first, just straight line going up. And this works nicely. Now let's turn it by 90 degrees. Okay, that worked correctly. Okay, that seems to be working. Let me finish this shape and we will see. We will see how our offset function works on this. Left. I want to create an L shape. This will allow us to test convex and concave terms. And we should probably move the line back to the beginning. Okay, so this is our next test example. We'll first draw it in its baseline.
Square Triangle says sorry for interrupting you again. but you will definitely come to the point when Automat will need to click some objects recognized with computer vision, so these movements can't be pre-recorded.
True. True, and this is a fair point. But I don't really want to weaponize Automat. Weaponize in a sense that when people put stuff online, they sometimes do this for free. And this is when people start to automate stuff on the websites. And it quickly turns into this fight between the authors of the website and the botters. I'm not sure it actually pushes the internet in the right direction. So I would like to make Automat easy to use, but I don't want to make it to optimize it for online abuse. This is not the goal. For botting, and if a website specifically tries to prevent automated access, they probably have a reason to do so. There are lots of twisted bad examples of websites which should not block bot access, but they still do. I think they are kind of spoiling the ecosystem, and actually, if you want to set up your own small website and you have problem because you are DDoSed or something like that, I don't want to become part of the problem. So I'm trying to do this in slightly responsible way. I'm not going to install some crazy mechanisms to prevent botting, but just nothing that helps spammers. Okay, and with this line. Okay, let's look at our path. By the way, square triangle, you can interrupt me. That's why I'm streaming my work. If I didn't want anyone to interrupt me, I would work offline. So, yeah. And thank you for this. This is a very good point. I can already see that you know what you're talking about, and So I used to do web scraping and this kind of stuff before as well. And also other types of stuff which was slightly irresponsible. And after having been in the on the other side as well, I see that it's not it's not always that big corporations are always evil. Sometimes they do the right things. Our path. Let's
Square Triangle says thank you, that was exactly what I was afraid of. Cause it would be a real threat when a program can trick CAPTCHA or something like this. Good to know that so experienced programmer as you have no intentions of creating a weapon.
And to be fair, most of the people don't do that. So when we had when we've been, because literally that's what we have been doing when I worked there. We have been trying to catch spammers. So we have been, like, a common problem is that spammers are not really that experienced, and they often don't develop their own tools. Instead, they take off-the-shelf tools. Like, for example, on Android, they were using some exposed, some custom modified ROMs. They were using like Magisk to hide their modifications, or online they were using like completely different sets of tools. The thing is, whenever those things were happening, and whenever like experienced white hat hackers were like reversing our detection code and posting this online, we usually were reaching out to them and just explaining them how we use this. And most of the time, not abusers, like the people who were developing this software were kind of very open. They were coming to us, and we have been having those tech talks when we have been meeting them, and they were telling us what we could improve. So most of the authors, even on the automation software, are responsible. And like fun examples is that quite often the people who write this software, like for example, there is this Magisk tool, which is for modifying Android devices. The guy who was author of this, he went to Apple then, and I think then he went to the Android team. I think he works on Android security right now, or maybe he left. But even though he works on Android security, and it kind of creates a slight conflict of interest, he still develops Magisk. And I'm losing my voice, so I will do a short break to code, and maybe I will recover. And this is a difficult situation with this corner here, because this corner, we know that we have to offset it sideways, and we are already doing this. But we also, if we want to properly shrink this shape, we also have to offset it vertically, and this is going to be tricky. But we will get to this. Let's try fixing those lengths now. Oh, yes. This should be cotangents, not tangents. And now we have a shape that shrinks and grows. It seems to grow and shrink slightly too much. So let's think about the math that is going on in here. So the first term is positive. So we have pi minus half a pi. Cool, cool. And we are dividing this by 2. Okay, so we have this line here. That's not it. So this first turn is wrong. Let me remove this stuff temporarily. I will print some stuff to the console, so I don't want this other arc to mess with it. I will leave just 2 line segments, so we have a line going up and left. Yeah, and this is a simple case, we can debug this thing. Let's try to draw this case. Oh yeah, so this is the case which we are trying to fix. So we know that we are moving by S in this direction. This shape, let me draw it a little bit larger. So we have a line from B here we have B, here we have C, and let's also draw our original. Yeah, this is how they look like. Here we have S. This is the S offset. See here. This full line, it goes in that direction a little bit, and then it hits point A. And the length of this line is L. Now, since we are offsetting this maybe I should draw this differently, because I drawn the S arrow in the opposite direction. So our offsetting, I mean, the situation is, I guess, symmetrical. But okay, I will have to draw this again, because this drawing is important. If I mess this up, you know, we will be fiddling with math this whole day. So let's do it properly. So we have this A line. It has length L. Eventually it hits our point B. Point B goes there. Here is angle beta, and if we want to offset this whole thing by S, the points will move like so. Normally I would use a tablet to draw this, but my wife borrowed it today, so too bad. The point C is going to be on the intersection of those two lines. Now, we can also draw delta L. Right, so if we have segment L which goes into the next segment in direction B, then we have to change the length by delta L. So this is what we have to find, delta L. Let's type beta here. Let me extend this line. Here we will also have beta. And here, and here. So we can draw a triangle here, and we know that the height of this triangle is equal to S. We know that this angle is equal to pi minus beta by 2. So we take cotangents of this angle, pi minus beta by 2, multiply it by S, or tangents. Let me check. Yeah, cotangents. Cotangents is the close one, and the edge which is close one divided by edge which is far away. times S. And this is pi minus angle. Okay, this is correct. And we are using tangents, not cotangents, because we are like inversing it. In C there is no cotangents function. Let me see. And the idea for cotangents is that we just use tangents by and divide by the tangents of the inverse. Should multiply here and that. That should be correct. But the difference is way too much. Are we doing this twice maybe? No, we are doing this just once. Let me print this angle. Yeah, this is 45 degrees. And now it works. What the hell? Did I change anything? I didn't change anything. Oh, yes, I did. I've put the divide by 2 in the wrong place. It should have been here. Oh well. At least now it's more readable. Yeah, this is how it looks like. You can spend 2 days fixing an issue like that. Let's see this part, because the next turn is concave. It doesn't seem correct. So here is what I will try to do. I will draw 2 lines. And I will I will do just a turn here, and I will draw this line. L3. Just to be sure that we are still doing this part correctly. This is the regular concave path, convex path. And here, instead of drawing 2 segments, I'll just draw 1 segment, because this is going to be easier to debug. Okay, it seems that we should be shrinking, but it's growing. So we have to change the sign this, but the sign should be based on the direction. I think this could be correct now. Let me see. No, that was wrong. Or maybe it wasn't. So what if this angle is negative? Yes, then we should subtract from probably minus pi. Let's try to draw the geometric example for the concave example. Yeah, the one where we were starting. If beta is negative, basically every place where I use this angle I can just basically use the absolute value of this angle. Okay, I think I know. I think what we are doing right now is that we are correcting the angle value, but we are correcting it at only one end of the segment. And if the segment has sharp edges at two corners, we have to correct both of them. Yeah, so the start of the segment is a sharp edge and the end of the segment is a sharp edge. All right. Yeah. Let's finish our shape. Let's see how it looks. No, this is beautiful. Yeah, this is what I wanted. There is a small discontinuity here because we are still not adjusting for the final turn. But I wanted to change the structure of this ArcLine a little bit. And the plan I have in mind with ArcLine, first of all, I would like to remove this end posse and end angle. They will break a lot of stuff. So the only reason we need them is because we have this line 2 function, not necessary. Line 2, goodbye. Now we don't need to update those things. We don't need to initialize them. When we're doing Arc2, we also don't need to update them. Okay. The class was simplified a little bit, but I would like to simplify it a little bit more. And the plan I have in mind is that right now we have this sequence of line segments and arc segments. And I would like to replace this with basically line will be just a straight line, always straight line. It will always be tangent to the arcs at the end and the beginning, but the arcs they will be able to have radius of 0 essentially. So if we see
NEG Borsa says hi.
yo. Hi Energy Versa. We're doing some geometry right now. Funky geometry. So what we... Okay, I just broke the compilation. But if I fix it... If I fix it... Yes.
NEG Borsa says okay cool.
We have this library that does shape animations. We're going to use it to create some effects, like ripples extending from objects. The thing is, I want to polish the API, the API of this library as much as I can. Because using a library with messy APIs, it's a tax that you just keep paying throughout the project. So we have this ArcLine here, and now we stop encoding the angle as part of the line length. We will also change those methods. So instead of arc2, we'll have turn by. Instead of polar line 2, we'll have move by. Okay. Everything broke. Everything. But let's fix it. So we don't have this, we have this, and line has just length. Okay. This is just a static function. If I remember correctly, yeah, it could be static. This is just utility that we are using here. The turn by is correct. Here are the functions which adjust the lengths of straight segments. I will comment them out for a minute. So when we outset this stuff, okay, when we encounter a straight line, we are going in this current direction. we're moving the point in the current alpha direction by the length. And if it is a turn, yeah, that's what we are doing, we are turning. Now, part of our code, I mean, a lot of our code broke, but it should be easy to fix. When we move by, we move.
NEG Borsa says, can I ask Q?
Sure.
NEG Borsa says, what is a ArcLine?
So, typically, if you draw paths, you can, like most of the graphic libraries, like in HTML, you have this HTML canvas. If you're drawing using Skia, Skia is a library used by drawing, used to draw by Chrome. It has a very similar API. You basically can compose paths of lines, Bezier curves, segments of circles. The problem with Bezier curves and those paths is that they are difficult to manipulate geometrically, so we have our own essentially class, which allows easy manipulation, easy geometric manipulation. So we can grow it and shrink it basically super quickly. It is just a linear pass through the line. Because it's very simple geometry, it's composed only from straight line segments and turns, which behave like circles. And at the end of the all of the geometrical operations, we can still export them back to Skia path and draw them. I will show you an example in a minute. I just need to get this to compile again. L3, turn by. Okay. Now, this is kind of broken right now. But the idea is that we have this shape and we can grow and shrink it dynamically. Oh, let me uncomment the nice example. This is the nice one. So we can create funny, smooth shapes and we can twist them. We're going to use this to create a ripple effect around objects and to properly calculate sizes, so that when we are drawing like edges here, we will use our shapes to do this. In this object right now, this hotkey object that I have drawn those shapes by doing the math kind of manually, but it's not going to work long term. Like, I cannot really, for every object, come up with coordinates of all of those points to draw. So this library is going to help us.
NEG Vorsis says AHH combining two primitives, but why I feel that this is wrong.
Well, I wouldn't say we're combining two primitives. I think the traditional paths where they had Bezier curves. So Bezier curves are super nice, but and you can easily find tangents, because if you had like the starting point and the control point, the tangent is just the line from start point to the tangent. It's very easy to find the normals and to at least offset the initial points, but it becomes very messy when you want to find the intersection points and when you want to offset the control points. So if you want to grow a circle or shrink a circle composed of Bezier curves, it becomes super messy. It turns into a diamond shape or a clover leaf. Inkscape and other programs can do this, but they do approximations, and they are sometimes wrong. And because we are using this super simple subset of shapes, we can do this correctly. And we have the case with arcs is basically already working, so we can offset path composed out of circles already. Now I would like to fix this case. So we have a simple turn left. When we offset it in the positive direction, it works okay, but if we turn it in the negative direction, not so much. So the place where we actually adjust this is here. And I think, so we already figured out the math to do this. So yes, that works. The thing is, I will move this because right now I was checking if the current segment is a line.
NEG Vorsis says I have zero experience with graphic, only drawing custom font on old screen.
Well, this is actually very close to drawing a custom font. In fonts, I always thought that fonts are only composed of those Bezier curves, actually. Can you actually do arcs in fonts? Oh, actually, if you know fonts, I want to ask you so many questions. So, fonts are a big thing. I really care about fonts. And I would like to have some nice font effects, because I am offsetting, shapes right now, but I would also like to play with shapes of fonts. So, for instance, do you know how are they called? So there are those glyphs in Unicode that can replace multi-char sequences. Do you know how they work? Is it, for example, how are they encoded in a font, for example? because those they have been a little bit problematic for me. And if we have somebody who knows the open font or TTF files, that would be cool. Oh yeah, actually,
NEG Vorsa says sorry disconnected. I hope I did not miss any important thing.
Yeah, you mentioned you kind of have some experience drawing custom fonts, and this is something that I kind of find interesting because drawing custom fonts means that we can create some nice like visual effects. I'm really into that. Are you familiar with the internal structure of the font? You know how the OpenType or TTF files are constructed?
NEG Vorsa says yes, but I used Bixmap only.
I see. And next question. I am going to take advantage of you since you're here. So, have you seen the...
NEG Vorsa says 128x64 screen in hardware Arduino.
I see. So I guess you were probably limited to like ASCII or maybe not ASCII, but some fixed width fonts. So the next thing I was interested in was the ligatures, because in fonts you can replace sequence of Unicode chars with a ligature that will draw, you know, a slightly different glyph, slightly different bitmap. I was actually trying to play with those a little bit. Yeah, but I wasn't really diving too deep in the OpenType specification, but it was so, you know, I actually was loading all of the fonts through FreeType, and FreeType exposes like a bunch of metrics for every glyph that you load, but I don't really understand what those metrics are and how to actually convert sequence of glyphs.
NEG Vorsa says yes, I know that I did not use fixed width.
Oh. Okay, so when I have let me see. When I have a font, I have this code which handles drawing custom glyphs here. Text shaping, this is the difficult path. Line run. I was working on those fonts so long ago. You're definitely not familiar with this part, because this is how just Skia does font layout. By the way, this is how Chrome does like font layout as well. Because Skia is the graphics library used by Chromium and Chrome. You know what? I think I will not probably find the issue that I had. I had some issues with, you know, emojis, but I'm not going to find it right now. I will record your username though, and I will ping you if I'm going to dig into this again. Probably in the coming weeks. By the way, what was your project about?
NEG Borsa says it this project in the Git.
Ha, you have probably hit some chat protection. Let me see. So Twitch likes to disable URLs in chat. So if you can just put space somewhere, it will probably paste correctly.
NEG Borsa says drawing menu and text left to right with limited resource 1 KB RAM on STM8 SMCU.
I know STM32 and STM8S. How much memory does this have? This is so tiny. This is so... Yeah, so in this amount of memory, I mean, you cannot use any libraries even.
NEG Borsa says old screen SSD 1306.
Yeah, 100 and like this amount of 1 kilobyte of RAM, 1 kilobyte of RAM. This is just insane. There is no way to load even like the most optimized free type in this memory. And there was probably no OS, I guess, as well. Can you send the link to GitHub?
NEG Borsa says BDF font in bitmap.
I really like text formats. For images there is this ppm. Yeah, I see that this bitmap font, it reminds me a lot of this ppm, another old format for graphics.
NEG Borsa says very simple. Okay, let's continue with the paths. Funny things are happening. Let's see. Okay, the simple case. The simple case is that should have a different sign, I guess. Okay, this case seems to be working, and here funny things are happening. Okay. Let me try turning the line in the other direction.
Turning right seems to work now, and turning left does not. Okay, let's go through the code and see what is happening with the signs. If radius is less than 0, okay, that's our case. We take S. We take the angle. We go through our funny math here. So the S is always negative. This is equal, in the simple case, this is equal to 1. Because that's the cotangents of 45 degrees, and our angle is 45 degrees. So this is 1. This is 1, this is 1. This is negative. So we should add this. Okay, and now for negative turns, if we are turning right, yes, let's see what's happening if we are turning right. If we are turning right, this becomes negative. So this is negative. In angle. this is one, and this is... So this is negative, and now this is also negative, so maybe I should just remove the direction here. Now, right turn behaves correctly, and left turn should also behave correctly now. Yes. And now let's fix this situation. What is even going on here? I will be uncommenting subsequent turns. We are shrinking this shape and growing this shape. This works nicely. Okay, this works. Ah, I see. We shouldn't turn by full pi.
NEG Vorsa says looks like you are routing PCB traces.
Well, actually, I'm going to use this library to draw, paths when there are connections between objects. So, not that far really. PCB traces have this nice aesthetic to them. Okay. We need to fix one more thing here. This offset is almost perfect, but the starting point also has to move. How can I do this? Maybe. So we are starting at some initial point. We are offsetting it to this side, moving through this shape. I'm curious, could we just set the final point to P? That would be silly. I will disable the other paths and focus on the one which causes problems. And we will do some printf debugging. We have just this one path. So if we follow all of the segments, I would like to draw the final point, because I don't know where we're finishing. So once I draw this path, I'm not going to close it. One way I could fix this would be if I placed my starting point along a straight edge. because then moving sideways to grow or shrink it would always be the correct way. Let me try not moving the point at the start of the offset function. No, I should add this. What I think I should do is here. Okay, just change the sign. Okay, and it seems to be shrinking correctly now. I don't really understand the code that I added just now, but it seems to fix it. Naturally, we still have a lot of edge cases, like what happens if the two corners touch each other. They should become like a spike, like a single corner, or disappear completely. What happens if the length of a segment drops to 0? Like the segment should disappear. So there are still edge cases that we might have to fix. Let me just write them out as to-dos. Fun thing, I don't think we are using P. Anywhere really. So it's totally unnecessary. And current alpha. also. This is a funny situation, because we can just remove all those lines. Yeah, and the shrinking code still works. Okay, so let's record some to-do notes. So our path is still not normalized. So two consecutive lines could be merged into one line, two arcs with the same center. Second point is the user must take care to finish the path. And I think those are basically the main ones. We could also mention the renormalization. So if we are shrinking the shape too much and the 2 points joined, we should probably update the sequence of points to actually reflect that. I'm not really interested in, writing a super general library, at least not right now. I'm just happy that we have this kind of shape and that we can already use it to update the shape of the hotkey. So let's also record. But other than that, it seems to be correct. Do we want to close it? Yeah, let's close it. Let's remove this circle. And yeah, let's once again check all of the test cases that we had. So we have this one. Oh, and there is one more I would like to try. The hexagon. Let's see if we can properly outset a hexagon. like this. Where is our hexagon? It's not here. Ah, we forgot to draw it. Yeah, we have nice smooth hexagon. Let's see if the outset function is okay. I'm really scared about this point. I think this could break now. It should work. It's growing okay. And it's shrinking okay.
NEG Borsa says cool.
Now the main task is not to get hypnotized by those things and continue working. The thing is, when I'm tired by thinking and I'm working on procedural graphics, I kind of tend to go in this state where I just stare at the results. Okay, let's remove test paint. So we are back to our baseline shape, and you see, this is what we had to do manually so far. This is how I was drawing this shape of the hotkey. Not anymore. Now I will, so temporarily I will draw it as a test shape. So the start point, we'll have to place the start point somewhere, but the start angle should be going upwards. And this is the X coordinate where we should start. Just for test, let's try drawing a straight line. This is slightly too high, but this is almost what we want. Just the y coordinate is. So this value, this is actually a bottom. Never mind. Key spacing plus key height. So we're drawing from this corner. That's not quite what I want. Inner radius, exactly. Okay, the start point is in the correct position now. Now we have to continue. Now we have to calculate how much upwards do we have to move. Oh, actually, we had this here. Key spacing is equal to 1 millimeter. Key height is 8 millimeters. And key base radius is 1 millimeter. So I want to go to, so this is key spacing, key height, by key spacing plus key height minus key radius. Okay. Yeah, exactly. And minus this thing. Cool. And now we can start turning. We have the first turn, then we have a short straight segment. I think this is the formula for this. So minimal touchable size is the constant that I'm using to store the size of the button, essentially. Minus key spacing. Well, okay. This is too much. Yeah, this should be divided by 2. Okay. Now we can turn by minus pi by 2. Nice. We are here. Now we have to go up. We could turn right away, but I don't really want to. I want to have a straight segment here and a very sharp corner here, so that we can make this key larger. So we should go up by yeah, I think this is the correct value. Okay, and now turn left. Yeah. In this direction. Cool. And now we will have a long straight segment, and the length of this segment is the width of this box, this whole box. Okay, and I think I should also subtract. So what I am subtracting right now? I am subtracting the final radius, that's good. Minus size of the button. I think key spacing. I think each instance of those okay. Yeah, once I kind of checked out what are the variables that I have available, it becomes much simpler. Now we can turn left. Move by. We are going down and again turning left. And finally, we're turning left again. Cool. Yeah, and this is the new inner shape of the hotkey. We could animate it. So now, if we want to extend it, we can just I would set it by border width. Yeah, and we have a slightly bigger shape. Amazing. We don't have to repeat all of those drawing commands. I want to remove this inner contour. Yes, the shape has changed. We probably don't need to do this outset here. Yeah, we can just draw it like so. Now I guess I can grow the F11 button so that it properly fills this space. Shortcut key width. You can see those places where I calculate widths of keys. Those values are actually standardized. So this is why the control key is always wider than regular keys. So there's like an ANSI keyboard, and it says that the control key should be 1.5 times base key width. Shift key should be 2.25, those are called units. So if you want to order custom keycaps, they all have to follow those sizes. This is still too large. I have to subtract the width of the button.
NEG Borsa says good to know that.
Okay, now we have the proper width. I will simplify this expression because it's so ugly. Frame width. So I can remove this frame width and this frame width. Cool. The key is wider. Let's center the text correctly. It seems to be a little bit off right now. Be right back. I just noticed another problem, is that when we calculate the width of the key, we only do this when we first build the widget. And I think this hotkey object, it is initializing it with a different string. Like, 5 or question mark. So we are using some function to update the name of this key. Yeah, here. So I will just add a function to do this.
Grandern just followed.
Gramdern says yo bro.
Yo yo, thanks for the follow.
Gramdern says since you are working on animations. Gramdern says you might know about this. Gramdern says so I need to calculate intersection surfaces between circles. Gramdern says I found a very easy implementation to calculate the area of the moon shape of two intersecting circles.
This is an interesting. Why had you had to say such a thing? I mean, how do you calculate? I think I know what you mean. So I don't have this as a chat on screen, but your description is very good. So I will try to put the chat window so that we can see this. I know what you mean. I know what you mean. You know, if you are following the math competitions, those kind of problems are actually quite popular, where you have to find intersections of funny figures. Let me open. Yeah, because integration is not integration, like just calculating the square area like a grid. It's it does, yes. Okay, there is a way to do this analytically. It's not a simple math formula, it will be an algorithm to do this. So we have a yellow sun, right? Oops. And we have two occluders. We can have Earth and we can have Moon. And we want to calculate just the area of the sun. Yeah, that's what you mean, by the way. So finding intersections of circles is fairly, doable, right? So we find all of the intersections of the circles. And we can also sort those circles by their, let's say, horizontal coordinate, horizontal start. And here is where this, maybe this is a better picture because the circles end in like much the same places. So the idea is that once you find all of those intersections, there is a whole class of sweeping broom algorithms where if you have like a complex geometric, like a mess of geometrical figures, and you want to calculate something out of this, like it's common for convex hulls, but it's also used for different things, like calculating areas also can be done with this. The idea is that you sort all of them horizontally, and then you go from the left to right. So first you consider this edge, and as you go, you consider all of the areas that you want to calculate. Because, if you imagine, if we zoom in, like the first, this segment, this is totally irrelevant, like, because here we have just the moon, But here there is a segment where we are starting to calculate the area of the sun. So again, this is a bad picture, so let me draw a slightly different one. But if you are just following this, you know, from left to right, you always have a situation where you have to calculate the fraction of a circle minus another circle, like a vertical slice. And calculating those vertical slices is actually doable because you always have two of them. You never have three. And when you have a situation like this, where you have like an edge of the earth, you know, when it might seem like it's becoming more difficult, but you just split the calculation into two. So then you calculate the area of this and this part on the bottom. So with a bigger example or cleaner example. So messy, yeah. So interesting points happen here, in this intersection, and in this intersection. And yeah, and at the edge of the earth and at the edge of the sun. So when we go from the left, we have edge of the sun and the first intersection. The first we encounter the edge of the earth, but it is kind of outside of the sun area, so we kind of skip it. So the first kind of important point is here. So here will be like the first area that we will sum, or here. Yeah, exactly. Then we will have like this slice and this slice. Yeah, basically yes. And if we want to calculate this, it still requires some math because we still have to subtract the area of two circles, but it is much easier because there are always two. And there will be a case where this whole sorting algorithm splits. Oh, nice. So it's going to be slightly difficult in this case because the equation that you're talking is about full circles overlapping. In this case, we are taking vertical slices of the circles. So the algebraic formulation might not be as elegant, but it can be done exactly still. Absolutely. Yeah, and under the hood, this is probably what libraries do. Those algorithms it's, if you know the general trick.
Gramdern says so that moon can be considered point-like. Gramdern says or very close to moon.
My TTS woke up. Let me disable
Gramdern
this.
says so that
Okay. I just disable this. No worries. Yeah. Yeah, I remember very similar problems to the one that you are describing, which had totally different, the optimal solution was totally different. It was to actually convert the problem to like a set of linear equations. But that was for, I don't remember what that was anyway. Could be, because when I'm thinking about this problem, I also try to think, well, what if those were like some, 3D objects that kind of intersected and touch each other, and, but it doesn't lead to any, more optimal solutions. It actually is still kind of funny. Yeah, anyway. I did. I actually worked on language models, although not very large. When I was I don't know what's SO3 and Transformers. I was actually finishing my PhD right when Transformers came out, and once you work on a document for a couple of years, you don't want to change it, when you're towards the end. So I didn't switch my method to use attention, any attention technique, but attention directing techniques like transformers, yeah, they are a big game changer. Yeah, the language models that I worked on were not as, they were much less capable, because a lot of people are talking about large language models, but they can be really tiny. So the ones that I worked with they were still neural networks, but they were 200 neurons. And because they were so tiny, I could propagate them back in time for a really long time, and I could do inference super fast. That was compared to large language models, where you have a token, a couple of tokens per second, with recurrent neural networks, tiny recurrent neural networks, you have thousands of tokens per millisecond. Also, when you train a language model, you have to, and especially a recurrent neural network, you have to because a single iteration of a recurrent neural network is very simple. But if you actually want to train it, you have to, in memory, expand it multiple times. So at each iteration, the neural network gets in another token and outputs another prediction. And to actually train it because when you train it, you are trying to force the neural network to remember relevant information from a long time ago, and to propagate this information through its hidden neurons in time. Yeah. During training, yes. During training, you do this a lot. And then during inference, it becomes ridiculously fast. Yeah, so the thing is, I worked with very tiny neural networks, and so, for instance, like, you know, each neuron, like of those 200 neurons, it is just a single value. It has like its own hidden, you know, state, but it is just a single value. So the whole information about the previous history of the text, you know, the prompt, the text that was written, you know, before the current point, the neural network has to encode all of this in just, you know, 200 floating point values. It's very lossy, and it can generate some text, but it is mostly garbage text. It is very, very coherent at the start. The way I used those networks was actually for completing sentences to accelerate typing. When you're typing on the keyboard, a tiny language model can still relatively well kind of complete your word, or, you know, type interpunctuation. It was very nice for programming, because programming is super well structured, and the recurrent neural network was learning to, you know, count how many parentheses was opened and was always closing, you know, on the right parentheses. So at doing this, you know, code completion, it was very efficient at that. But once transformers came out, you know, I think now recurrent neural networks still have this, you know, infinite history, at least theoretically. In practice, they are hard to train to actually remember relevant stuff from history. So there are some mixtures right now. There is this RWKV networks, which are like a mix of transformers, and they are not quite recurrent, but they are linear in a sense that they can, it simplifies some math, their structure. Yeah. Yeah, I mean, you're right. This could be dangerous. I'm not so pessimistic though. I'm not so pessimistic because you can also do cool stuff if you can design custom proteins. You know. Oh, okay. I see. Yeah, so in protein folding, transformers are like really, they are like just a natural fit there. because in transformer, tokens which are far away can kind of influence each other. With recurrent neural nets, it's more, I think they are better at representing like casual, when there is a time dimension being, when a time is part of the model. This is where I think recurrent could still win with transformers. I heard about this. Still undeciphered. Yeah, to be honest, I am a little bit surprised that, yeah, what you're saying is like 100% correct. There is, you can build a transformer out of Voynich manuscripts, and not transformer, like train a language model and look for similarity of this. Like try to identify which word translates to which other word. Yeah. How does it look like? Let me see. You know, just from looking at this, it already seems more like maybe not necessarily European, but could be like Arabic or, you know, from this area. Because, you know, in Egypt, China, Japan, Korea, and so on, they use slightly different scripts where you have ideograms. Yeah. So the way you usually do, you know, you probably know how to do substitution ciphers, because yeah, the way you mentioned that this manuscript could be solved, I guess you're thinking of a similar technique where you look at the statistical frequency of letters, you sort them, and then you can just map letter to letter. But you can do this if you know the target language. And in this Voynich manuscript, yeah. Absolutely. I think if we ever, you know, contact aliens, then we'll probably use neural networks to translate from our language to theirs. When I think about this, I feel it becomes kind of messy when you start to figure out the details. So let's say you have word like embeddings for tokens in this text. Let's say you tokenize it on the word boundary, because there are like spaces here. I guess they are words. You tokenize them, you define like embeddings. You train those embeddings to model this language with like word to vec or something simple, so that the embeddings are simple. And then, but then the embeddings are, because they are trained together, you know, each time you train a language model, it generates like a different family for its embeddings. So the embeddings, they work together. But if you take embedding from, you know, trained on one language model, and then, you know, another embedding with the same dimension but from a different language model, they could represent different properties at different locations in this embedding. So they are still difficult to correlate. So still some things to figure out. Though. But I agree that this is probably the way. Mm-hmm. Yeah. This manuscript, it cannot be, the cipher cannot be too difficult, because the person who wrote it, they had to translate on the fly, you know, the letters from their own alphabet or some kind of writing system to this, to those symbols. this morning I was playing with Stable Diffusion. I just wanted to try and see if Stable Diffusion recognizes Voynich manuscript, how well it can generate its pages. Okay. So this is SDXL Turbo. It's not super capable, but this is all I can run on my PC, so without it crashing the stream. Oh, it probably won't reproduce the manuscript itself, but it can certainly create stuff in the style. Showing. It can probably draw different, things in the style of Voynich manuscript. Computer keyboard. Let's make it more pronounced. This is Voynich manuscript showing a group of people. The style of text is slightly different, but the general feeling is there. So I don't have, I haven't looked into guns. I just played with diffusion models. I was actually, I'm not a specialist in this area, but from general stuff that I'm hearing is that guns are less capable than diffusion models. At least for, generating convincing, pictures. I'm not a specialist though. It's just I heard that all of those, generation tools like Midjourney, DALL-E, and so on, they all use diffusion models now. Even though originally DALL-E was a GAN, like the first DALL-E was a GAN network. Well, I'm not I'm not a specialist in this, so I just followed some articles on online, like on Reddit and on YouTube, and figured out how to use those things. And there are different versions. So I know Stable Diffusion pretty well. I don't know nothing about Midjourney and very little about DALL-E. I was following the papers when they were coming out a few years ago, but recently everybody keeps their secrets close, so not many papers are really coming out anymore. At least not many impactful papers. No, I'm not practicing anymore. After I got the PhD, I kind of left to focus on work. It's not that bad. One fun thing about university is teaching can be really cool. Teaching can be really cool, and if you can get a team, because like a group that you can lead, this is also very nice, because then you can really, explore ideas and work with like a group of people. And you don't really have these economic incentives to make money then, because the government pays for your research. I actually had to. We have this requirement in the law that if you are doing a PhD course, you have to have like X hours per semester. There was like a minimal quota of teaching. So, and you meet all types of people. Some people are there just to get a paper, and some people are there because they enjoy it. And those are the nicest to work with. Yeah, so I have a friend who also went to get a PhD, and I was kind of, when I told him that, man, you can easily, get like a corporate job with like this many zeros of salary, he still preferred to teach, and he was not in computer science, he was in math. And the people at the math faculty, they are in their own world. They have like, because he was like really good, not because like he did a lot of papers, but he was super charismatic, he was super precise, like a quick thinker. And he was like a celebrity among students. So people like that. Because imagine, a math faculty, and math students. Often when people go there, they are interested in math, and they created this amazing culture when they are like just really, really into math. And he was, like a local celebrity. I think because the money is shit in teaching, so you have to kind of have fun at least doing that. Sure. See ya. Okay, we got a lot of stuff done. Let's submit it. I see some old code. Yeah. I think just remove this. We don't need this anymore. Okay, now we can fix some stuff. Let's try, for example, so whenever we hit Ctrl, if the object is on, we have to turn it off. And we will repeat this in every case. Okay. Now I disable control. F11 alone works, and Ctrl Shift Alt does not. Now let's enable Shift, and Shift 11 works. Cool. Okay, this to-do is done. We are displaying the correct name. We can toggle modifiers. Now the big one, allow the user to set the main hotkey. I think there was a way to call this XCB grab key, but instead of specifying specific key code, I think there was a way to call this with, so that it grabs any key. Let me see. So here's what we could do. We could say XCB grab any. So when the user clicks the key to grab, we call grab with this one and mask any. Yeah, let's try this and see how it goes. This state variable overlaps with the on-off that we had here. So what we will do, so what we want to do is for this key, when I press it, I want it to capture whatever I send. And within the hotkey object, we currently have two kind of properties that record state. We have this on-off property, which tells us whether the hotkey is active. Now it's active, we are getting events. Now it's inactive, we don't get any events. But we also have a state property, and we don't use it at all right now. But maybe we should. Because once I click this button, I want this object to enter a new state where it would indicate somehow that, hey, I'm currently capturing, the key. Okay, let's keep coding and see where the problems pop up. when we click the key, I would like it to switch to a color like this one. Maybe slightly brighter. Nice. I'm going to do it like so. For modifiers, any modifiers, and any key code. We will push this object into system event hooks so that we receive the callback from the system. We do a silly cast to get the key. Yeah, instead of this state I will just keep a boolean. Because this boolean, I was thinking that you can only record when the button is in the off state, but it actually makes sense to allow recording in the on state. So those two booleans, on off and recording, they are orthogonal. So now I have to think really hard, because this all could lock my system. Okay, let's see. Let's say A, Z, unhandled even 0? Okay, this color, instead of setting this directly, I will do this in the draw function, so that it can actually represent the current recording state. Can remove this from here. And we can remove this from here. I'm curious, what is even 0? I worry it's some kind of error. Not F6, button release, button press, key release, key press. I see no event 0. Why did we got one? Okay, this is the issue. There was already a grab for some combination of the keys, but this could actually be good because we could iterate over all keys and establish grabs for all of them. This could actually be a nice way of checking if any other app already has this key grabbed, because I assume, yeah, there are some, like on my system, for example, there is OBS. OBS has some key grabs active. Okay, we will continue this after a short break. Hello back. Back to hotkey hooking. So this doesn't work. That means that we will have to iterate over all keys, and for each key we will set up a separate hook. X11 is messy. It would be nice if in the error message that we cannot set up a hook, it would actually tell us, hey, there is another application which holds the hook for a key. I know there is another application because I have OBS running and it has some shortcuts. Oh well. Let's find the enumeration that we have. No. The header. And if we want to iterate over each of those keys that are potential hotkeys, we'll just store them in an array. All of this has to be reformatted. Crap. Too fast, too fast. Yeah, and now we have our array.
We We reached our followers goal of 10. Thank you everyone.
Awesome. Thank you so much.
Nicolene just followed.
Nikolai, thank you so much for the 10th follow. It's like an anniversary. If you have any questions, feel free to ask. I'm streaming my work because, yeah, I am open to chatting, not just working. Okay, so here is what we're trying to do. We have this nice object which can intercept hotkeys. When I activate it, it properly intercepts when I press F11. I can change the modifiers at runtime and it properly handles that. But what I still need is this thing, the ability to specify a different key. This is returning an error, but in a weird way. According to the documentation, our request to X server works, so it returns like a proper response. But then the actual error code, yeah, is returned in the main event loop. Okay, I can do this, grab key checked. Why didn't I read the last paragraph of documentation? And now it should crash. Beautiful. Failed to grab keyboard. Okay, we are not going to do this anyway. We will have our own approach. Arguments are wrong. So we have connection, other events, then we have root window, modifiers, key code, pointer mode, keyboard mode, That should be fine. And the error is saying what? Okay, we have to cast it. There we go. Now, if we fail, then I would like to log failed to grab key. So now I should have a nice dump of all of the keys that we can grab and keys that we cannot grab. And also, when I grab everything, I want to begin intercepting. And grabbing is actually much simpler. Here I can pass and grab any. Although, let me check the documentation for the ungrab. Nice. Okay. Yes, this is exactly what we want. Here. We'll grab everything. We change the state to recording to indicate that, and if we get a key, we record it and do it like so. Should work. We couldn't grab two of the keys, but they are unknown. What? Okay, that worked. A, S, D, F, and this is causing error. Why? So we are getting this unhandled response type free. I'm guessing this is from the key release event. And there is key F here. I can press A. And now when I activate it, Ctrl A causes this event. Some funny errors happening here. Let's log some stuff. Some tiny log message, just to see what is happening. When I press A, X11 returned 38. Okay, 38, which is internally $73. Well, okay, we have somewhere here, 73, A. And the text is A. Okay, and if I press F, which is internally 0, that shouldn't be the case. Because if this is the case, then our function, which converts X11 key codes to keys, must be missing some values. ISDF. How could this happen? X11 returned 41. Okay, this is why. We translated just a couple of keys. A lot of text editing awaits us now. I'm so glad we have multi-cursor editing. Although this could be a macro as well. Maybe macro would be better. Oh no. No. I wonder how this hotkey is going to work. It seems to work, okay. How do I do control? Amazing. This actually works. So to activate this hotkey, I have to hold right control and then I can press left control. Yeah, I'm going to leave this. This is perfect. Yeah, this works. This code is so messy, I'm surprised it works. So it doesn't work in all cases though. I think I messed some constants. Because when I click like left control, okay, that works. Left alt works, space works. Right alt becomes numpad enter. 108. Yeah. Let's see X11 key codes. Maybe this is somewhere in XCB headers. Let's try XKB common. Keysense. So one of the problematic keys was, or let's try one working key. Left control, 37. And 37 in hex is 25. Nope. Keysems are not what we want. The key code that we are getting is for left control is 37. No header seems to define it. Probably I shouldn't have to use strip grep. Now we have some meaningful, right? This is 37, but this is octal 37. Oh no. We are left with Google. Okay, I have to read this carefully. Okay, I have to find the proper list of key codes. escape and 1 to 9, 0 minus equals this table seems to be correct. Let's update everything. Backspace tab. Comma dot slash shift keypad space caps lock F1 to F10. And then we have num lock, scroll lock. Minus, plus. have a working F11 and F12. Yes, they are correct still. And this is where things should change. We don't have a lot of keys to change, so that's good. Hello. So, we spent a lot of time editing text, but we should have fixed the hotkey. So we can grab most of the keys on the keyboard, but some of them were wrong. And now we will check. -09. All of this seems to work. Left super works, left alt works, space works, right alt. This doesn't, this is like a custom key. That works. Right control works. Print screen. Scroll lock doesn't work, but pause works. Why can't we hook scroll lock? Yeah, we even failed to grab the key. Oops. Insert, home, page up, page down, and del, down, left, right. It works. I can never create a hotkey, which is left control, control, left control. And the crazy thing is this works. So right now, I started this hotkey. When I press control, nothing works. I actually have to hold the right control, then I can press left control, and now we intercept it. Crazy stuff. Some small bugs here I still want to fix. When I start this, here, I get messages about failing to grab two of the keys. First unknown and then scroll lock. I want to see what they are. Oh no. I've done something silly. So I started the hotkey, I started grabbing the keys, but then I closed the app. So it still has all of the keys grabbed. I cannot do anything on my computer now. I have to SSH from another machine. Yes, and kill Automat. Now it worked. Hey Adam, I didn't notice you were here. Yo. I don't have such a good view on the YouTube chat, so I might have missed you for a minute. We've done tons of work now. We can submit all of that.
PGRGRGRGRGRGRGRGRGRGRG just followed.
Thanks for the sub. It's a library. It's a library. So on YouTube chat, I got a question about how do I render the window. I can give a quick overview. Let me just submit this stuff. So most of this is no, it's not SDL. I set up the window myself, calling the XCB on Linux and WinAPI on Windows. Then I set up Vulkan, and I have a tiny library to do Vulkan setup. It's called VK Bootstrap or something like that. and then I have the graphics library used by Chrome. It's called Skia. And Skia, I can basically issue commands kind of similar to what I would do in HTML canvas. Like I have paths, I have gradients, so I can issue those I can use those primitives, and Skia will take care of translating them into proper Vulkan commands. And I can merge this with whatever I want, my own stuff. So for example, shaders, if you've seen, there is like a flaming fire. So there is like a separate shader, which is kind of merging with the Skia geometric things. Yeah, I really like that library. It's hard to set up, but once you have it set up, it is super performant, and yeah, and it can do really complex stuff. Like, text rendering, for example. Text rendering is, hard if you want to do it in most game engines, but this is like it's a vector library, so it knows how to draw shapes, and it's fairly accurate. Yeah, so I can play with stuff. And there are no textures here. This is completely drawn from C++, which is probably a bad idea. I think I will regret this, but for now I draw it like that. And the fun thing is that if you draw shapes like that, the amount of data that you actually have to transfer to draw this thing is fairly small. My hope is that eventually I will have like a separate browser, and browser will be able to connect there. And because of those commands, they are compatible with JavaScript, JavaScript canvas. The same stuff that I'm rendering right now in C++, I can convert to JavaScript canvas commands and send it over to HTML client. So hopefully I will be able to set this up as it will be possible to connect remotely to this program. There is one more small thing I want to change now. And after that, I will do something completely different. We'll stop working on Automat. The one thing I wanted to do is that sometimes when I click this button to change the hotkey, I don't want to change the hotkey. I want the next click to disable this. So I will find this function. And now let's try some difficult things. Let's say I activate this hotkey. It works, and now I try to change it while it's active to, let's say, Q. Okay, Control F11 stopped working, and Control Q is working. Cool. Yeah, it works. Yeah, for now, that should be enough. We can remove this to-do. Now, I also wanted to do some changes in the appearance of the hotkey, but we will do this another day. Now I would like to work on something different. Let's try writing a proper script for TTS, text-to-speech. So on Twitch chat, a couple of hours ago we had issues because the TTS service that I'm using, it just wasn't keeping up with the TTS from the chat, like the messages on the chat. And also I want to have TTS for both Twitch and YouTube chat. So I will write my own script. So let me change the stream title. Okay, so this is why I don't trust Copilot. Let's see what ideas does it propose. There is a WebSocket connection to Twitch chat. Interesting, interesting. I want to see this chat Twitch TV. Okay. Let's see how this will work. Let me set up a new Twitch account. create an account, set a password. I'm doing this on my separate screen. Okay, that should work. Let's see if this works. Pass has to go first. Okay, let's see. Yeah, this is what happens if you try to work with confidential data on stream. I had to reset the password on the second stream because it flashed on my screen here. Okay, I managed to authorize as my bot. I guess now the bot should be in the chat. It sounds strange. When I use my bot account, to access the chat, it doesn't pop up in the user list. So strange. Okay, I am getting those messages. Okay. I guess. We should have requested this capability. Then we can get list of users on chat. Oh yeah, and now we got ping ads. We will probably be kicked out. So let's close it and reopen. Actually, we don't need those capabilities specified here. We just need to watch for messages. Sorry, wrong chat. Okay. So we can receive messages from me and from bot. Now we have to just pass this to TTS. It has to download like 1 gigabyte of stuff before it can run. So many models. This is like, am I running out of disk space? I just want to do some TTS. Sorry, I have to stop this because I am actually running out of disk space. Okay, now I'm back to 20 gigabytes.
Say it like you mean it.
That was a solid voice. Okay, I will close the bot account. Let's see what options do we have. We have Let's just create a small sample file that we can play with. Okay, so from this small tool, I can already see that it runs faster than real time, so that's good. is deep speed. No. Let's hard code this to false. Let's try running this thing.
Say it like you mean it.
Okay, that was a decent voice. Okay. Okay, so we will use PyDub just like here. But we're going to construct it from the data from memory.
Say it like you mean it.
Oh god. So let me try to save this. I will see how many channels it has and what's the width of each sample. Two. And one channel. Oh god. So this is stored as floats, float 32. And just print all of it. Let's see. Now it looks reasonable. Let's see if you can play it and not go deaf. Cool. We don't need to save it anymore. We don't need to print any of this. Remove the seed, not interested in that. That works nicely.
Say it like you mean it. Say it like you mean it.
That was LJ. NG.
Say it like you mean it. Changed my life, learned about its history.
Say it like you mean it. I reckon sometimes you.
Say it like you mean it.
Say it like you mean it.
Say it like you mean it.
You also may have heard this next James. Every so often, everyone assumes that because
Say it like you mean it.
everyone assumes that because
Say it like you mean it. We had a guy, Gary, so I said, I'm just gonna put it out there. He said, well, how about Alpha playing? And I felt in this instance, if you want to use this on your own computer, you must have an NVIDIA GPU.
Cool. We have a decent TTS.
If you want to use this on your own computer, you must have an NVIDIA GPU. Tom's Diner.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU. I would say from the games, they
If you want to use this on your own computer, you must have an NVIDIA GPU.
This one is nice.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
You were always a good man of business, Jacob. Good man of business, Jacob. Business.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU. Outside, the black of night had given way to the pink. They leaped upon us and smeared our cheeks with wet, sticky kisses.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU. If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
If you want to use this on your own computer, you must have an NVIDIA GPU.
Right, we have a working Twitch connection and we have a script that can play voice. Let's clean it up a little bit. Cool. So, I guess next step is to actually hook this all together. How could we do this? So, a lot of the operations that we are doing here are blocking. Does Python have threads? So the way we could structure this whole system would be that we will have one loop which interacts with Twitch chat. It has to have this while structure because we're using sockets to talk with Twitch. We will need some kind of main loop that will receive messages and send them further on for processing. We could use... So it would be nice if there was a way to interact with this whole system. So components could... so it would be possible to manually, for example, delete backlog of TTS messages, or have some like automated error recovery. So, for example, if Twitch connection dies, I don't want this to influence, everything else. So, having multiple processes may not be a bad idea. So, could have Twitch bot. connects to IRC, saves messages to saves messages to a TTS queue. And the messages will be appended at the end, although I guess each bot will be able to like log the file and append it in the middle or wherever they want. Then we need to have the component which does the audio processing. Watches the TTS queue file. Generates wave files. And we could also have the TTS player, like a completely separate component that well, it could even like monitor my microphone audio to make sure it's not playing new samples when I'm talking, for example. But this component will be like the final piece of the system. Removes and place lines with wave files. Yeah. this is how it could look. Controls on other components. I haven't done Python GUI in quite some time, but it's a good opportunity to revisit this. We'll continue doing this on Friday. Alright, so see you in 2 days. Bye.